आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
Vigyan Ki Awaaz podcast series aims to popularize new ideas of science and technology, which highlight STEM, science, technology, engineering, mathematics, and medicine. This brings to the surface the efforts and researches of Indian scientists, which is desired to bring a change in community learning and teaching, access to knowledge of resources, and social paradigms. Our goal is to spread the name of indigenous Indian research stories and their masters among the masses of society in a very easy manner. Bose Institute was set up in 1917 by Sir Jagadish Chandra Bose, the founder of modern science in the Indian subcontinent. It is Asia's first modern research center devoted to interdisciplinary research and bears a century-old tradition. The institute was founded as not merely a laboratory but a temple, with its principal aims being the advancement of science and diffusion of knowledge. Swami Vivekananda, Sister Nivedita, whose influence is reflected in the institute's emblem of Vajra, was significant in the setting up of the institute, and Rabindranath Tagore were among those who had consistently inspired and supported Jagadish Chandra Bose in his endeavors. Ever since the establishment of the Department of Science and Technology, Government of India in May 1971, Bose Institute has been an autonomous grant-in-aid institution of DST. Over the last century, the institute has endlessly strived to preserve the legacy of its illustrious founder. In this podcast, we are happy to present Dr. Sanat Kumar Das, Associate Professor from Bose Institute. His research work is related to global warming, which is one of the major environmental problems we are facing presently, and he has great findings regarding that. But before going into more details about his research work, let us hear from his own voice about his academic journey.
Hi, I am Sanat Kumar Das. Actually, I started my research journey from Physical Research Laboratory, Ahmedabad. We all know that is known for the space and earth science. So I started my research journey with the background of MSc, Masters in Physics. When we started my research, that time the pollution or aerosols are much more important because from where it is coming. And Ahmedabad is a city where the anthropogenic aerosols, means man-made air pollutions are high, as well as we are very close to the desert. That is the natural source of aerosols. So our challenge is that can we distinguish what is coming from man-made and what is the natural dust? So that is our thesis work, and I did. And how they affect to the environment, the warming, global warming, how they affect to the temperature increase globally, and Indian climate, how it is changed. That is our research. And that is where I started my journey. Then I go to the postdoc in Taiwan, and then after the Canada, and then shifted to from the direct effect, that means solar radiation, how the warming effect. Then we started how these aerosols are going into the cloud. Does it affect on the cyclone or typhoons? Does it affect on the precipitation? But this all we are seeing from the physical point of view, how the physical laws are governing on that, how they are flowing. And with that expert, I joined Bose Institute in 2013 as a Ramanujan Fellow, DST Fellowship, and then I become the assistant professor. Now I am an associate professor. But my research also slowly shifted. And then in 2019, our new director suggested me, Sanat, can you see that you are talking about the aerosols which doesn't have the life, but Bose Institute known from the biology. Can you know that there is a bioaerosols? And if these microbes present in the air, how they move. And I started learning and research on that, how they are existing, because atmosphere is not the natural habitat for that. Then microbes are different types, bacteria, fungi, and they are affecting on the health. And I started that research on, and then COVID came. And then I realized, yes, this is the research we should do. And we started during the foggy time, when fog occurred, the microbes are very high, and they are affecting on lungs, they are affecting on skin. We have published that paper, and once we published, that was the first paper in India that airborne microbes are really important, and they are also affecting the airborne diseases, like you can say that COD, that chronic diseases, respiratory diseases, these are affecting. And then people are started thinking, and they are contacting me, like IIT, and they have a big project on the fog. They are also started, Dr. Das, can you join with us? And then started on thinking that non-living particle and the living particle, how they are interacting.
Dr. Dash speaks about his collaborators and how they are doing the research work.
I have a good team, and Bose Institute is known for the biology, so we have a good scientist on biology, and I am seeing from the physics point of view. So we have a good team, and we are trying to see how this thing happen. Then, and as well as we have a station at Himalaya, that is Darjeeling. So these pollutants is going to that station, and Darjeeling is one side that is actually boundary of the two nations, Nepal, China, and this side. And we are trying to see that how the microbes, does it coming from China, or it is coming from our western side, or it is coming from Indo-Gangetic basin. These are the research we are now doing, and we are very fascinating that how it is surviving in that cold temperature, because when the microbes are alive, they need the nutrient from the air, that is aerosol they are giving, and as well as UV radiation is much more important. So we have several projects. So we go to that extreme climatic condition, or the cryosphere, or low temperature condition, that Arctic and Antarctica. And I visited Antarctica, and now I am very soon, January, we are going to Arctic, and try to see how the microbes are present and how they survive, because now it is winter, totally dark. That means solar radiation is not there. So how that temperature they are surviving, how from where they are coming, that is local or continental there. It can imply to our Indian side at Darjeeling, and that is also cold, and UV radiation is much more higher. How they survive, that is the scientific question we are trying to see.
Dr. Sanat Kumar Dash went to Antarctica, and he has shared his experience here.
Antarctica, when I visited that time, that is the very eastern region, and we have collected several pieces of aerosols. There also we find black carbon. Black carbon is coming from the most vehicle emission. But Antarctica, there is no vehicles. There are penguins are living. They are not producing black carbon. And we are tracing from where it is coming. It is actually continent. The Europe and the Asian, that dust and connect with the carbon that is transferred to the Antarctica. And they are responsible for the warming. And that warming actually affecting to the glacier melting. That is the same thing we have also published one paper on Himalayan glacier, how this black carbon is going to the top of the Himalaya. They are giving the warming effect, and then it is actually affecting to the glacier melting, and that glacier melting is affecting to our input of the river water, fresh river water. And nowadays we have a big problem that glacier melting is accelerating. That means melting is very fast. If it is so, then in future we have a problem of the fresh drinking water. We will not get. That is one thing. And second thing is that temperature is increasing. That is most important. That is low temperature and we have a high temperature over the ocean. So there is a temperature gradient. If this temperature is increasing, then temperature gradient will be low. That means force will be low. Then monsoon will not go to our Himalaya. It will move to the Pacific Ocean towards the East Asia. If it is so, then we have again crisis of fresh water from the rain, as well as we have a problem for the making of fresh glacier. So both the way we have a problem. So this problem can be solved or we study further if we go to the polar region and how that pristine environment is affecting from the both that the living and non-living particle. That is our actually.
Dr. Dash speaks about some of his findings related to rapid environmental change.
Then there is a direct effect of pollution to the climate. So that's why if it is winter is become more stronger, we are feeling more cold, but in a delayed method. Why it is delayed? Because the monsoon is not coming or going. It has a delay. That circulation I have shown, the temperature gradient has a different. But when it is happening, it is intense way. But the cold is become more colder, warm is become more warmer, and when the monsoon rainfall, it is more intense. Why? Because of this aerosol. There are two kinds of aerosol. One is the hygroscopic, another is non-hygroscopic. But non-hygroscopic means that vehicular emission, this thing. But they are become hygroscopic because they are coating, that mixing with the other thing. And this is going to very fast because non-hygroscopic particle, if they attach to the living particle is always giving the water to the non-living particle, and they become hygroscopic. And they go to the cloud. And they are making sometimes, it depends on what is the percentage of the living and non-living thing. If it is non-living is much more, then the rain will be low. But if it is opposite thing, then rain will be high. So we cannot predict which one is high. That's why our model, atmospheric model, has a large uncertainty. Because we don't have large observation and we don't have large information to give that model. And that's why we are seeing the effect. But sometimes we predict nicely, sometimes we don't, because we don't have that emission and the observation of that thing.
Dr. Sanat Kumar Dash speaks on the solution.
So we all know that our environment is changing. So we have to work together to stop the pollution. But it is very difficult. Our government is doing like Ujala, it is our project that from the domestic thing, how the emission is small way we are trying. Even for every people, those who have a car, they should do this servicing, so less amount of producing. Another thing is that deforestation. We can cut less amount of trees. At the same time, the urbanization also we need. So urbanization, there is one thing we are trying to do in the urban cities, that what is called the top of the building, we are changing the albedo, greeneries. So we are making these things. So these are the perfect solution and we can work on that.
Dr. Dash speaks about his global collaborators.
First thing is that aerosol, I have already said that Canada and they are collaborating with us. Second thing, when we work on that bioaerosol, that Japan is very interested. There is a institute, Kyoto University. They have a protocol and they are working on that. They contact with me and started collaborating with me that how that bioaerosol are affecting to the environment over in the genetic plane. And we have a project on also that MOES, that IITM people and the NIO, National Institute for Oceanography, they are also interested to work with Bose Institute, especially for me to see how the bioaerosol working on that. So in future, what we are trying to see that like weather forecasting, similarly we can we do the health forecasting, means that see there are lots of airborne diseases from the microbes. Once their season change, that wind is also carrying the microbes and we are affecting, like if Kolkata, if you see monsoon time, that we are more sneezing and dust effect. So can we forecast which kind of disease we are going to face for these people, local people? And for that we can collect the medicine and doctor, they are getting ready with that. So it will be as a health forecast, we can do it.
Dr. Sanat Kumar Das speaks on the way forward.
We are using small instrument to measure this bioresol. That is all indigenous. Means Bose Institute, we are trying to, in our workshop, we are trying to make small instrument to collect that and then analysis their DNA analysis, gene theory, how they are changing in gene with the pollution we are trying to do. So if that industry, if we get the patent of that instrument, then we can make it a large way. So industry can help us to make that small amount in a large way, that we have a NGS. So that sequencing we can attach with that, so we can get a real time how the microbes are changing, which type of microbes are changing, so we can get it. But we are working on a small scale, so industry can help us to make it. Industry, they are thinking in a engineering point of view. So if they want to, how the biology or the physics government, means of the governing law, how it affect to the, how the airs are moving and this thing, that small instrument, the fluid dynamics, what we are using. So if we pass this knowledge to the industry, then industry also helpful, and industry can pass this knowledge that how they are engineering, how they are modifying the small instrument to make it more real-time effective. So it will be both the way we can help.
We are thankful to Dr. Sanat Kumar Das for providing us with his valuable time.